Hello and welcome to the program in the C++ Part 2 series. Before we get started, please like, comment, and make sure you're subscribed to the channel. When you do subscribe, you get access to, you get notified when new videos are posted, and it helps you navigate throughout YouTube a lot easier. And if you're unable to do that, please go ahead and set up your YouTube account. It's free, it takes less than 1 minute to set up. So with that said, let's go on to our first video, or first exercise in this video, which is going to be Programming in C++ Part 2, Programming Exercise 13.8. And this video, or this one exercise, we're going to rewrite the definitions of the class complex type so that the arithmetic and relational operators are overloaded as non-member functions. Write a test program that tests various operations on the class complex type. Format your answer with the 2 decimals. Well, you will set our precision in. Let's see what we got here. Let's look at our header file first. This and see things. So we have a fault here, but we'll get to that at the bottom. Go load. So these are public. Have void. Set complex, get complex. Select type. And then our privates are real part and imaginary. Both double. So one thing we can do to clear up that fault up top. Go down and end if. Found end if. That should clear up that fault, and it does. All we did was go to line 49 and add our end if. Clear up this fault when we open up if. So let's go ahead and close that out for now. And let's go to our most of our work, which will be the implementation file. As you can see, there's several errors showing. Let's go down and make sure we didn't miss anything. So let's see. Here we got this first line 28. Changes where it started. And we'll jump on this, but first we'll take a quick break and be right back after this. Alright, welcome back. Let's get straight to it. So we can remove this complex type right here. And then this, we'll add 1 on the end of it. And comma. We'll do the same thing to make complex type 2. So change this 1 to a 2. So we're going to use this a few times. Get rid of this constructor here. Copy and paste this whole thing here. 1, 2. Copy that. We'll save the paste for later. And return. You want to change this to 1. Dot real part. Change this to 2. Part. Same thing here. 1 dot imaginary part. 2 dot imaginary. That one's cleared up. So let's do this again. Let's take this out. This one is good. That was the same. Gotta be the same food. And that. Go back to our move that. Yeah, we'll pick up here. Move this one on line 54. And let's paste what we copied up top to this one. Move this constructor. Complex type will equal temp. Temp dot real part equals 1, 2, 1, 2. Okay, 1 dot real part. 2 dot real part. dot imaginary part plus 2 dot. And we can return temp. Same thing here. Next. Type here. And paste our constructor and 1 dot row part, 2 dot row part, 1 dot imaginary part, and 2 dot imaginary part. First, 1 dot 2 dot parts. 1 dot 2. Turn temp on that one. 2 dot there, so that's and let's go to 76. Paste our 22. Constructor. 78 clicks. Oh. Alright, let's go 1 dot row part, 2 dot row part, 1 dot imaginary, 2 dot first, and yeah. Same thing. Do again. Here, 2, 2, changes to 2 because other clicks. 2 plus this other. This one would also be 2. And 2. Here, 2. Then there's other 2 real nothing. 2. One part 2 imaginary parts. 1 1 those again. 4. There. 28. Pause that there if you need to do that. We added constructor complex type ampersand 1 and the same thing constructor complex type ampersand 2. I'm going to separate those. We'll remove this complex type here and then double semicolons. And then we added 1 dot row part, 2 dot row part, 1 dot row part, 2 dot row part. Next place, scroll down. Yep, there. Still works. Real part. Yeah, we don't have to change anything. Okay, there. Let's go down. 54. Change these the same way. 1 and 2. Move that complex type. 1 dot 1 row part, 2 dot row part, 1 dot imaginary part, and equals 1 dot imaginary part plus 2 dot imaginary. Alright, so scroll down again. Composite. Scroll these here. 2 dot 2 dot. Yeah, scroll up times so you can see that. Alright. Next, let's jump on the main. Let's take a quick break and be right back. Alright, so let's go ahead and close that out. Open up our main. Let's start with our include. Gotta add our IO map. Let's copy that. IO manip. Yep. Do the same thing. Let's do this time with our header file. Complex type .h. Here. Namespace is there. Down. Our code. Start with let's start off 11. Complex type 1. There's 3 numbers. 2, 3. One's gonna be 6. Will just be 7. Alright, so let's see out. Do our set our precision. We'll do it like this again, but we'll do it slightly different. See out. See out. Precision. 2. See out. Space. Number 1 variable. And line. Here. That. Here. It's 8. And 2. enter complex number. Space semicolon. Let's see in variable and see out. See out. New value of num2. Equals num2 and 3 equals num1 plus num2 colon see out. We'll pick back up right after this quick break. Alright, so let's continue on. Let's see out. Line 15. Last time we copied and pasted a lot of this, but since I got rolling, might as well go ahead and type it up. Copy and paste the last part of it. So I might take this part up again. Quote space quote, and then the number2 variable. Come on down to the next line. Quote minus or quote space minus space. Number1 plus number2 variable. And in this part, line. See out 16. Same thing, let's go to 9. It's equal space space. Call number1 times number2. The variables 1 times number2. Hit line. Let's go 3. Number1. These again, change the signs. So let's go like 18. So num3 equals num3. Num1 minus equals so num1 plus num2 9 20 1 divided by num1 should look. Oh, that. Let's go ahead and take a quick look at this again. Show you the code. Pause if you need to. And read it. That is it. Roll back up. And you can pause it if you need. And that is it for the main file. Go ahead and close that, and let's go ahead and try to run it. Let's go ahead and open that. All right, got it restarted. Let's try to run it again. Now it's running. See what we got. Either a complex number. There we go. All right, so we got that. Looks good. Let's calculate that up and see if we're good to go for this exercise. Wait for it to calculate. Take a little time. And there we go. We have our green and 100%. That one is good. So what we'll do is we'll move on to the next exercise. It's going to be programming in C++ Part 2, programming exercise 13-10. We'll jump on this one. First, we'll take a quick break, and then we'll right into it. As you may have noticed, the program exercise 13-9 wasn't shown because it's not on the list. We don't have it. It's practice or it's not graded. We're going to jump right into 13-10, which is, let's see. Rational fractions are of the form a over b, in which a and b are integers and b does not equal 0. In this exercise, by fractions we mean rational fractions. Suppose a over b and c over d are fractions. Arithmetic operations on fractions are defined by the following rules. A divided by b plus c divided by d equals ad plus bc divided by bd. A divided by b minus c divided by d equals ad minus bc divided by bd. A divided by b times c divided by d equals ac divided by bd. And a divided by b divided by c divided by d equals ad divided by bc, in which c or c divided by d does not equal 0. Fractions are compared as follows: ab opposite cd if ad opposite bc, in which op opposite is any of the relationship operations. For example, ab greater is less than cd if ab bc. Design a class, say fraction type, that performs the arithmetic and relational operations on the fraction. overload the arithmetic and rational operations so that the appropriate symbol can be used to perform the operation. Also overload the stream insertion and stream extraction operators for each instant or input and output. Write a C++ program that uses the class fraction type to perform operations on fractions, among other things. Test the following. Suppose x, y, and z are objects of type fraction type. If the input is 2/3, the statement CIN x should store 2/3 in x. The statement cout x plus y should output the value of x plus y in a fraction form. Statement z equals x plus y should store the sum of x and y and z in fraction form. Your answer need to be in the lowest term. So also, we've been doing this already. You're just going to do it in fractions. And so task 01, overload the plus, minus, multiplication, and division operators. Task 2, overloaded the comparison operator. So we make sure we do that. Now we have to add these folder new files. So let's say fraction type. Good. Okay, so yeah, we have to add our own files here. New file, click on new file to do that. And we're going to do fraction type CPD. We got to add our own implementation file and our own, or implementation file and our own fraction or header file. Main is already presented. Nothing going on to it. So once you add that, see how I did it. Once again, you click here on this emblem, it says new file, click it, and make sure you name it fraction type.h. For your header, do the same thing. Click on this, click new file, and then type in fraction type.cpp. Those are two we need to add. Usually they're already here and started, but this time they want us to know how to add them, so we'll do so. So let's go to our header file first. And looks like we got to do all the work. Let's go down to 3. Let's go down. Let's go include IOStream and include fraction type H. Namespace. STD. Already in the fraction type, so let's start this over. We got this. Delete these two. We're already in the fraction type. We don't need to do that, but we do need to do if in def H fraction. That, and then find H fraction. And of course, this if and def is going to stay there until at the very end we go ahead and put our indif hashtag indif on there. Let's do include IOStream Good. Let's do our class. Find our class here. Class fraction type. Let's do brackets. Here we're going to overload stream insertion and extraction operators. do friend poststream ampersand operator. Let's go poststream ampersand comma constructor fraction type ampersand. And we'll do semicolon. Here we'll do friend iStream. Just copy, save our time. First, this is going to be iStream, and operator is going to go the opposite direction. And everything else is going to be the same. Let's make our public. Let's make these public. And start this one here. Let's go void set fraction and integer num. Another integer called Dan. Alright, so let's take a quick break here. We'll be right back after this. Alright, let's get back on it. So here, go down, and we're going to do our another constructor with a fraction type. Same it, integer number, and let's initialize it to 0, and then integer Dan, same thing, initialize to 0. That has to be 1, denominator 1. Can't be 0. Okay, got that. Let's go over here or copy and paste some of these. Very similar. Fraction type operator plus fraction type and right t fraction. Let's go comma. Let's just copy this for all the other operators. Space. Change this to asterisk minus subtraction. So that when these are the overload. So we got that done. We want to end up clear that fog up. Do this right now. Let's see. And clear this up. And put your semicolon there since it's a class. And do this up here. Alright, so let's go back to work here. Now we do an overload. Now we'll overload our relational operators, which are the equals, not equal to, and so on. So this will go pretty quick. Operator. We'll do equal. Same thing. Fraction. Type. And right. HT. And outside on this one, these have to be constructors. We can do same way we did those. And we'll tighten these up. C 2, 3, 4, 5, 6. I did one more than I needed to. But let's go not equal to. Let's go greater or less than or equal to. And just simple less than. Then let's go greater than or equal to. And then greater than. So we don't. So here. Private. Integer. Numerator. C. Integer. All right. So let's bring this back. Go. All right, so let me show you what we typed. You can pause it as if you need to. This is going to be the fraction type header. Go ahead down, pause as you need more time with it, rewind it as needed. Have it. All right, so we got the header done. Go ahead and set that one down. And open up our implementation file. We can close this up. This one's where most of the work is going to be done. And jam all this, but it's not too bad. We've done it before. Let's get the first part knocked out. Let's go ahead and do our include. We'll do IOStream. And we'll do include. And we'll reference our header file. Fraction type. .h. Again, using namespace std. And let's come down. Push this down. So let's go. Let's take a quick break. We'll be right back after this. All right, let's go here. Let's go with an OStream and ampersand operator. Ampersand OS, comma, constructor, fraction type, ampersand, fraction. Like what we're doing with this file. Let's go OS, fraction type, fraction dot numerator. And let's return OS. Here. Copy this. Function. And just the iStream. Just the iStream. IS. It's the same. Brackets. Let's go char. CH. Character. fraction dot numerator. This will get the numerator. Yes. Read the discard character. There. Next, we get the denominator. So is fraction. Then we're going to return is here. Go. Over. Do that. Starting. Cool. Fraction type. Colon. Operator. First one is equal to sign course. Fraction type. Brackets to clear up the default. Let's return numerator. Apply that by right. FR. Denominator. Equal here go. Denominator times by default. Camel case. Fraction. Now that we got that, we'll do the rest of the operator the same way. We'll copy the thing and up that down here. What we'll need to change here is does not equal. Put the explanation of that. And here times rate of r equal. Anything else? Same. Do that. Let's come here. Copy it again. This time we're to less than or equal. Same except signs. Down to the next one. This one's going to be just simply less than. Change this less than sign. Back down and greater than or equal. Greater than. Come on down here. Here. Now let's take a quick break. Be right back after this. All right, come on down. There, let's go ahead and start now. Constructors. Fraction type. number, integer denominator, in, bracket. Now numerator equals num, and if in, we'll call it deno. Deno equals 0. Coutts. Denominator. Oops. Denominator. Denominator. 1. Here, let's go else. Next one. Again. Load operator. Fraction type. Fraction type. Colon, operator plus. Start off. Fraction type and fraction. Brackets. easier on ourselves with other overload the operators that we copy this whole thing. Control C down to 6. Copy, paste it. Multiplication operator. This one is first type temp. Temp numerator equals numerator times right. Here. And do plus. Make sure that application. So yeah, right numerator. That's so. Tip denominator. Right FR. Semicolon. Okay. Temp. Time. Copy it again. Alright, let's take a quick break. We'll be right back after this. Alright, we got faults or something else is missing. I know what it is. Let's do this to our fraction. Let's copy this 61 72 fraction type this right here because we're again, but we have to set fraction. This here 74, paste it there. We'll say void fraction type set type out the way. Number it Dino, where it was num, should be exactly the same as that. Dino, that brings here. Let's operator again. Clear it out. Go up here, we need to do semicolons with entities. Mess it on the first one, this is a copy and paste. Yep. Fill in. Two more. Fill in. Should look clean, it is clean. Come on down. 9. Copy it again, I did leave. Temp. Let's copy this stuff first. Got 87 gets it all. 7. Subtraction on temp numerator times denominator minus denominator temp denominator temp. That one. And different. Copy paste it anyway. This one will be this vision. This one. Now, let's go. If right of R and 0 see out not divide line this else. One of them. This one, temp dot numerator equals numerator. Numerator. That. And temp dot denominator equals R dot times and return temp. That's all for that one. Show you this code. Please pause if you need to. Going all the way down. Top of it faster, but pause or rewind as needed. Code on that one. And now let's go ahead and go into our main. Go ahead and take a quick break. Be right back after this. Alright, so let's jump on this main. Starting with our other include statements that we need. We need our IO manip on this. Let's copy that. Then let's do our header. Use fraction type.h. Anything else is still there. Let's move this down and let's space here. Let's start with fraction type, just like we've done so many times before. Now 1. Right. And then I'll copy and paste the other 2. This becomes number 2. Number 3. And this one I'll add numbers. It's going to be 5 and 6. 6. And then semicolon after that. Alright. So let's set our precision again. See how fixed. See out 0 point. See out set precision. Oops. Number 2. See out 9, 7. 7, 1 equals 1 and line, semicolon, here, slide 8, 2, and 2. See out 9. Enter the fraction. Form A B for the fraction, semicolon. Let's do Cn, set of fractions, number 2. See out. See out 12. New value of num2. Num2 space equals space 9. Num2 variable. See out 14. 3 minus variable number 3. Oops. 9. See out line 15. Number 1. Plus 2. That equals minus this equals num1 1 plus num2. See out again. One times 2 Take a quick break right there. We'll be right back after this. Alright, so from here, let's copy this, but we're going to paste it right away because we do line first, and then number 3. Changes 18, 19, so we go 3, 3, same, 1, going to be minus, equals, correct, 1 minus num2. Open after take this multiplication to bracket m1 close bracket here and just a multiplication, so keep the space in there, then open close bracket here, base equals base, and num1 divided by 2, 9, 0. Alright, show you the code. Stop. Fill it down easy. There you have it. Come back up to the top. You can pause it as you wish. Now, let's go see if I can run this. That. But it's enter this time. That. Let's go. We got dollars. Exactly. And that. Calculate waiting. Let's go main. Here. Anybody see a dollar sign get put in here? I don't. finding as far as the hints. So plus pass to minus pass, station pass, division fail. Get the divisions and right back. All right, so let's go to your fraction type implementation file and go down to line 137.
This might answer your question. Fractions genres include Roth and classic
thank you.
Roth.
Here we go. Line 137, close to the bottom of the implementation file. This should be right FR numerator. Here. Once you've done that, nothing else. Again, that's the fraction type CPP implementation file 37. Temp.denominator right FR numerator. Okay, let's close that out and run it again. Play it again and it should be clear. Dollar sign deal. So let's go 4, 7. Tell us. Tell us that. Same thing, but let's calculate it again. Okay, fine. Stuck with that. I get a clear precise. Here calculates. Well, I guess it wasn't asking us to put out any information because we did get greens and calculate grade for that one change. Good to go. That's your 100. The issue. So no input was needed or expected from there. So that's all for this video. Thank you for joining again. Make sure that you like, comment, and or subscribe to the channel to see more. Not just from this course or this subject matter, but a lot more to come. All right. So take care. Thanks again. Have a wonderful day, and we'll see you on the next one.